sometimes you hear about a fourth plasma, but that's under extremely harsh, different, strange conditions. So we're going to talk just about the basic three. Can anybody tell me one? Solids. Okay? We have solids. Let's hear another one. Liquids. And what's our third? Gas. Okay, if we want to show that chemistry-wise, if we have water and it's in the solid state, in English we say we've got ice. But for a chemist, what you do is put a small S behind it to indicate it's in the solid state. And in theory, we should be able to take any substance and do this too, but that's not quite true. If we add heat to this, we can turn this into the liquid state. So we use a small L to signify that. And then if we add even more heat to it, we can change it into the gaseous state, but of course in English we use the word steam. But here we're going to indicate it that way. So all we have to do to make these changes is add heat. If you want to go left to right, you add heat. If you want to reverse it, and these are reversible processes, we remove heat is how a scientist would say it. Now in everyday life we'd say cool it, okay, or chill it. Well, we're really taking heat away from it. So it's really more precise. You're taking the heat back. So we get back to here, and then if you want to go all this way, we have to remove even more heat. Okay, in theory, you should be able to take any substance and do that too, but that's not true. Let's think of an example. Water does it just fine, and we know about water in everyday life. What about table sugar, sucrose? It's probably, you have some sitting at home, maybe in a sugar bowl, and it's solid state, under normal conditions of room temperature and pressure. Let's say you get the idea you would like some liquid sugar. You're making flan, or whatever. So, you're going to take that sugar, put it in a pan, heat it very, very gently, probably with some stirring, and you can get it to melt and go to the liquid state. Okay, but if you've done that, it's no longer just pure white. It starts getting kind of yellowish, brownish looking, because some of it is decomposing. Because sugar isn't very heat stable. So let's say you have this great idea. You're going to vaporize the sugar. Okay, so you're going to vaporize the sugar, and you just have to walk in a room, inhale, and take a hit of sugar, and have all this energy. Really a bad idea from several standpoints. Number one, if you're sniffing it, it's going to your lungs, and it's probably going to re-solidify and kill you, so not a good plan. If you want sugar, to up your blood sugar level so you can think more clearly, you want to get it into your stomach to digest. You don't want it in your lungs. But there's another really bad reason. You can't heat sugar that high at room pressure or atmospheric pressure, because if you do, it will fall apart, and you will end up with black carbon grunge and water vapor. And so you're not going to have gaseous sugar, you're going to have decomposed sugar. So the point is, not everything will run through all three of those states. Let's think of some everyday words we use. If you're going from solid to liquid, what do you say you're doing? What's that process called? Melting. And if you're running it backwards, if you've got liquid and you want to turn it into solid, what's the word we use in everyday life? Freezing. Okay, now, we're not necessarily doing this one at the boiling point temperature, so I don't want to hear boiling. Okay, liquid to gas. What's the word we use for that? If you set out an open beaker of water for several days, what is it doing? Evaporating. Okay, if it's going back the other way, you have some steam. You walk into a room where there's a whole bunch of steam. Condensing. Now, it is possible We don't usually see this in everyday life, but under certain conditions, you can actually go directly from the solid state to the gaseous state and bypass this thing altogether. It doesn't mean you go through it fast. It means you just flat out bypass it. Does anybody know the word for that?
Sublimation.
Excellent. Sublimation. Or subliming. And there's actually a word to go back, but I don't hear chemists use it normally. Deposition. It's depositing is where that word comes from. Okay, now let's go over here and let's think of some properties. This isn't going to be exhaustive because later on in 1412, if you take it, we're going to have a whole chapter just for solids and liquids. And at the end of this semester, we'll have a whole chapter just on gases. But just some of the properties. And let me get you started with this. If you have a solid, for instance, the cylinders you were using in lab number 2. These cylinders, that's solid state. I mean, people don't have a problem with that. But characteristics or properties, this has a definite volume. Okay, you in fact took the volume of it. Now you may not have gotten the same thing with the 2 different techniques, but it has a definite volume. And unless you do something pretty drastic, it has a definite shape. Okay, you'd have to take a hammer to it or lots and lots of pressure to flatten that out into a flat sheet or draw it out into a wire. So definite volume, definite shape. Now, if I get down here to gas, I'm going to skip over the liquid for a time being. If you have a gas sample, there's no definite volume. A gas sample, now we're talking about the sample as a whole, not the individual particles, atoms or molecules. Sample as a whole. Okay, hypothetical experiment. I have this cylinder of hydrogen sulfide gas. Now, if you know what that is, it has the odor of rotten eggs. Unpleasant, but it's worse than that. It's very, very toxic. More toxic than carbon monoxide. And carbon monoxide gets the bad press. Okay, excuse me. So, I have this cylinder of it. That's its volume right now. But I'm going to have an experiment, hypothetical. I'm going to crank it open, and that gas is going to get out. Well, what I want you to do is when you can smell it, raise your hand. Or if I let out enough of it here, you'll be falling out of your seats. Okay, dead or really, really sick. Okay, so that's why it's hypothetical. Okay, so as soon as you smell it, you raise your hand. Well, you can't smell something unless it's in your nose, particles of it, and it's reacting with your body physiologically. Disgusting thought. When you're cleaning the cat box, if you can smell it, you got particles of that up your nose. I mean, it's just a few molecules, no big deal. I mean, it's still disgusting. It's not like chunks up your nose. Okay, so if you can smell it, it's there. And so when I open that up, immediately these folks are going to raise their hand, they can smell it. And I would bet, I've never actually tried this experiment, I would bet within a minute, even the far corners, they would be able to smell it. That gas just takes up whatever volume you make available. First this classroom, then down the hall, all over the building, and we would probably have to evacuate at least second floor. Okay, so it takes up whatever volume you make available, and it's got no definite shape. It starts out the shape of that cylinder. I let it out, it's now the shape of the room for the sample as a whole. So we say, no definite volume, no definite shape. Then when we get to liquids, I've got this liquid right here in a 1 liter container. And a liter is just about a quart in the English system. Okay, do I have a definite volume? Sure. So we say liquids have a definite volume, but do they have a definite shape? If I would take this and pour some of it into here or some of it into here, it's going to take on the shape of the container. So we have no definite shape. And again, I want to stress, I mean the sample as a whole, not the individual particles. So I want you to think about this. Whatever characteristic we think of, usually solids are at one extreme, gases are at the other extreme, with liquids intermediate between the two. Not always, but that's the usual case there. Now, we think about density. Density is defined as mass per unit volume. Okay, if we have a solid, like the cylinders that you were working with, you'll have to visualize it because I can't see what happened to it. Okay, density of most solids. If you had to say high, medium, or low, density of solids tend to be high. So density for solids tend to be high. Whereas density of a gas, density tends to be low. And then usually density for liquids is medium, moderate, in between, whatever word you want to use. Okay, now let me get up owl here.